Hi guys, welcome to Programming Knowledge. This is Tanay Singh Hania.
Now let us code the Perceptron algorithm. Let me show you. Okay, so let me just open it up. Okay, now to part. Okay, good. Now let me open a new notebook. Okay, so I'll import few libraries. Please import pandas, std, and import matplot library, matplot and library, pyplot as plt. Okay, I'll assign a random seed to, okay, to get the same answers. Just you can assign any value. Now let us define some functions. Say step function. We will first assign the step function. It will say take a value t. If t is greater than or equal to 0, we will return 1 or return 0 for anything else. Now we will define prediction. So it will take x, all the values input and the parameters weights as, and would return the step function x of np dot matrix multiplication. We will multiply x comma w and add the bias to it. Take the 0th value as it would return the np array, the matrix multiplication. Okay, cool. So invalid syntax. Okay, I guess we left out. Okay, cool. Now let us define the perceptron step, basically the trick part where we will assign x, y, w, bias, and a learning rate. We can assign a default value of 0.01. Now, so for every value, I will take length of x. I will iterate over every value, get a y prediction. From the prediction function, I will assign the x I will send in the weights and the bias. Now, if the y the actual minus y predicted is equal to 1, that means the actual was 0 and predicted was minus 1. So we will get uh, that value 1. So I'll just assign the weights. We have to add the weights. So x I update the 0th value into the learning rate. I'll just copy this and we have to also update the bias, okay, with learning rate. Now else if yi the actual was minus y prediction is equal to minus 1. So that would happen if the predicted value was 1 and actual was 0. Okay, so in this case, as I told you, we have to reduce the, okay, so what I can do is just copy this and reverse the signs. Okay, cool. Now I will just return my weight and the bias. Now let us define the train perceptron algorithm. It will accept a x, y, some learning rate. Now another thing I had to explain is that till what time we have to run the number of iterations or the perceptron step. Basically, how many times we will move the line to find the perfect line. We could define number of epochs, that is the number of iterations it will perform. Basically, we can say 25. We could experiment over 100 and other to get a perfect line. I would just define the maximum value I find in this x dot t 0. Okay, now let us define some random weights. So I'll find an np array with np.random.rand. We have to find two values, 2 comma 1 dimension. Okay, and some weights np.random.rand. We have to find of 1 dimension, 0th value, so it would give the mean, and add the max value. Okay, so let us define boundary lines. Here we will store the values such as the slope and the constant value of a line. So let us iterate in number of epochs. Okay, so next up is we will get our weight and a bias from the perceptron step which we define. We will send x, y, w, b, and the learning rate. Okay, then we will add it to the boundary lines. What we will add a tuple of minus w0 divided by w1 comma minus b divided by w1. So this would give me the this would give me the slope, and this would give me the constant, that is the intercept. Okay, so I'll just return the boundary lines. Okay, cool. Now we have defined every function. Now let us read some data. So read the CSV data.csv. Let us look at the data. Okay, x, y, and a label. Okay, cool. So I'll get x, that is data.location. I need every row with the labels x and y. For y, I need data.location. I need every row and the column label. Okay, I'll just get the values. Okay, nicely defined. Now let us look at the shape of the data. Okay, 100 comma 2 and 100 values. Okay, cool. So let me plot the data for you so that we can visualize what the data is. We need every row, 0th column, and every row, first column, and color would be defined by the labels. Okay, nice output. The red ones we can say accepted, yellow ones as not accepted. Cool. Now let us get a result out of our train perceptron algorithm. We will send x, y. Okay. There's some kind of error. Invalid index to. Okay. Let me see what we did. Oh, okay, sorry. Okay, cool. So this would give me a matrix of 1 comma 1 dimension. I need the 0th value. Okay, and train. Yeah. So let us look at the result. So this would be the our um, the slope and the intercept. Let me plot the line. First we will plot the data and just grab the same line. We have plotted the data. Now I'll get the values from the result. I want the last iteration as it would give me the perfected one. Theta value would be the first one, and the intercept would be the second one. Now let us create the predicted values. I'll just multiply x into the theta plus intercept. Okay, plt.plot would plot the values x, y2, and the color equals to red. We will get a red line, and plt.show. Okay, so we found a line somewhere around here. Yeah, so that is all for the perceptron algorithm. Thank you so much for watching the video.